Voyager 2. It is America's last funded mission into deep space. Indeed, it may be the last mission of its kind. We'll be talking live about the mission and the spectacular pictures it's sending back with Jet Propulsion Laboratory scientist Carl Sagan. We'll look at a massive and creative effort to lobby new support for future missions, and we'll look in on another mission control at a high school in Illinois.
This is ABC News Nightline. Reporting live from the Control Center for the Voyager mission, the Jet Propulsion Laboratory in Pasadena, California, Ted Koppel.
Good evening. Let's go through some of the easy material first. That, behind me, is an exact duplicate of Voyager 2. Had Voyager 2 failed, that spacecraft was to be its backup. But Voyager 2 has succeeded spectacularly. Since it was launched 4 years ago, Voyager has traveled almost 1.25 billion miles through space. Tonight, it is a mere 750,000 miles from the planet Saturn. And by tomorrow night at this time, it will pass by Saturn a relative hair's breadth away, only 63,000 miles. So much for the basics, for the almost unbelievable accuracy of the mission. Even more important, though, is Voyager's bountiful photographic harvest. Our guide, as he has been on similar missions in the past, Dr. Carl Sagan of the Jet Propulsion Laboratory, who is, at this moment, in one of JPL's control rooms. Carl, what's the very latest?
Hi, Ted. Well, the very latest is an obscure moon called Hyperion, which maybe you can see in these two images. It turns out, first time in human history examined close up, to look like a peanut. It is, however, about 200 miles long, and it is oriented in a very strange way. It is an outer satellite. It's very big to be so non-spherical, and here is the latest picture of it, looking around at a different orientation than we did in the previous picture. The spacecraft is flying over it, and we get different views at different moments. And it's very clear that this lumpy, peanut-shaped moon is a very different sort of object. Its origin and dynamics and the reason for its shape are, at the present time, still mysteries.
Carl, is it my imagination or just my ignorance that I do not recall having seen that kind of an irregularly shaped object in space?
Well, there are a few asteroids which are lumpy, and the two moons of Mars, Phobos and Deimos, are lumpy. But this may win the lumpy sweepstakes.
All right. Can you pull back a little and give us a somewhat broader look at what this whole mission is about?
Sure. Here's a bird's eye view of some of the key events that are going to be happening in the next 2 or 3 days. We are with the Voyager 2 spacecraft in the Saturn system. This spectacular, historical exploratory venture is aimed at examining Saturn and its rings and its moons close up for the first time in human history, in tandem with the previous Voyager 1 spacecraft. Voyager, an exquisite, semi-intelligent robot, was launched 4 years ago from the Earth on its billion-mile journey to Saturn. It slowly approaches the planet, examining its clouds. We do not see any solid surface on Saturn, just its multicolored clouds. The spaceship reorients itself so its particle and magnetic field detectors can examine the environment surrounding Saturn to look for radiation belts and the solar wind, the faint particles from the sun that interact with the magnetic field of Saturn. As Voyager examines the rings, it will obtain a motion picture of the mysterious spokes, the dark radial patterns, which you can see here in the rings. This circle shows a star named Delta Scorpii, which will wink out as it crosses behind the rings. And then, as the Cassini division, a break in the rings appears, the star winks on again. This experiment will permit us to determine the width and density and number of the more than 1,000 rings that make up the Saturn ring system. Here, the spacecraft is just about to pass into the night side of Saturn, where its infrared spectrometer examines a moon as the moon is eclipsed by Saturn. The shadow of Saturn falls on the moon, and the rate of cooling of this moon will give us important information on the nature of the material on the satellite surface. The spacecraft reorients itself again and will photograph the lovely ring system, pass through the ring plane, and examine the braided ring which you can see at top left, something absolutely unexpected. Here, Voyager 2 is about to photograph the moon Tethys, which has an enormous valley running for most of its length. Each of these squares represents the field of view of a separate picture. They will be put together, made into a mosaic, so we will see the whole planet. After many such examinations of the 17 or so moons, the 1,000 or so rings, and the patterns in the clouds, the spacecraft leaves the Saturn system on its long journey to Uranus, to Neptune, and out of the solar system.
In a moment, back live with Dr. Carl Sagan for more on what the mission has already discovered and what still lies ahead. Back with us again from what they call the Blue Room here at the Jet Propulsion Laboratory. It's from this control room that JPL releases some of Voyager 2's photographic harvest. Carl, I guess the best way to resume is just to ask you to pick out some of your favorite plums.
Okay.
They've really gotten some good stuff, haven't they?
Yeah, there's just an amazing harvest of pictures. You know, there's tens of thousands of photographs of Saturn and its rings and its moons taken by the Voyager 2 spacecraft. Let's take a look at some pictures here. Here, for example, you can see the ball of Saturn and the ring system. The Saturn itself is composed of hydrogen and helium, but what we're looking at is just atmosphere and clouds. In the next picture, we can see a lovely, recently taken picture which shows the rings. You can see a break in the ring here through which we see the clouds, and then the shadow of the ring with its breaks here, and then the brightly colored clouds of Saturn over there.
Carl, let me just interrupt for
Sure,
a quick
Ted.
question. A moment ago, a member of the crew who was watching your essay before was asking, how does Voyager pass through the rings?
It doesn't pass through them. It passes outside of them, but not too far away. So if you imagine a ball with a plane coming out of it there, we pass on its outside from above to below the ring plane.
So there is no actual contact with the rings?
We sincerely hope not.
All right, fine. On to the next picture.
Okay, here is something which may look like an abstract expressionist painting. It is, if you had ultraviolet eyes, this is what the clouds would look like. This green oval over here, which in ordinary light would be brown, is about the size of the Earth's moon. Saturn is a very large planet compared to the Earth, and we are seeing an exotic meteorology here. If we now go from the planet itself to the ring system, we can see an image of an enormous number. In fact, the number may well turn out to be much more than 1,000 individual rings and ringlets. The solar system itself, in its earliest stages, some 4 or 4.5 billion years ago, may have resembled the Saturn rings, with the planets forming in particular places in that solar nebula. There's a great deal to be learned about the origin of the solar system and even about distant galaxies by looking at ring systems of this sort, of which Saturn is the most spectacular example that we know of in the solar system. The spokes that we saw in the movie a moment ago whip around this racetrack, are formed and dissipate and may be tiny particles the size of the particles in cigarette smoke, but that's still very much an unresolved issue.
You still have no idea what those spokes are?
There are many ideas, but I think it's fair to say that nobody knows. This is a stage where we're acquiring data and where the data is far outstripping the theories. However, there we go. One remarkable finding by the Voyager 1 and 2 spacecraft is that this ring, this thin ringlet, is surrounded fore and aft by two so-called shepherding satellites, which it's believed are responsible for the stability of this thin ring, which maybe has the consistency of a smoke ring. If we only take pictures, we are restricted in what we can learn about. The photopolarimeter will examine a distant star, as we saw in the movie, as it passes through the rings, blinking on and off. That'll give us some information. And the radio experiment, which transmits radio waves through the rings to the Earth, has just gotten some spectacular results in which the particle sizes making up the ring system have been determined. The biggest ones are about the size of a small house, and the little ones are maybe about a meter across. And we're beginning not only to map the gross structure of the rings, but to get an idea of the distribution of individual particles, which are colliding, coalescing, dissipating, reforming. There is a dynamic happening in the rings of Saturn.
Carl, do me a favor before you go on to your next photograph.
Yeah.
Give us some sense of how photographically you are able to determine what the substance is that you see.
Well, we haven't determined chemical composition this way, although from the Earth, by looking at sunlight reflected off the rings, it is very clear that the rings are made entirely, or at least mostly, of ice. These are giant glaciers down to small snowballs floating around, in orbit, around Saturn. The thickness of the rings is something like a mile. Their lateral extent is something like 70,000 miles. So the rings are much thinner compared to their lateral dimensions than a piece of paper is.
Any reason to believe that the size of these rings has changed over the millennia?
It is even possible that some of the rings, like the one we saw being guided by the shepherding satellites and the twisted F ring, change in the course of hours. This is not a system which is necessarily locked solid and invariable over millennia or millions of years. There's a great dynamic. There's a great deal of change happening.
Got some more to show us in your slideshow?
Got some more to show.
Good.
This is a Voyager 2 image of Titan. Titan is a moon with an atmosphere denser than the Earth's, composed of nitrogen mainly, the same thing that composes our atmosphere chiefly, and methane. And the featureless disk that we see here, there's almost nothing to be seen, except a little polar cap at the top, is due to a dense layer of clouds which almost everyone now agrees are composed of complex organic molecules, that is, molecules based on carbon. There is a kind of chemistry going on in the atmosphere of Titan, which in some respects is similar to the chemistry which 4 billion years ago on the Earth led to the origin of life.
How far is that particular moon from Saturn?
That is a very outlying satellite, much further relative to the size of Saturn than the moon is from the Earth. In fact, the big moons of Saturn, they have kind of nice names. Why don't we say them? I probably will mispronounce them, but this is the order. Mimas, Enceladus, Tethys, Dione, Rhea, Titan, Hyperion, Iapetus, and Phoebe.
All right, less than a minute for the rest of the show.
I just want to show one other moon, and that is Iapetus, which you can see is composed of a very dark region and a very bright region. This is the biggest contrast between dark and bright in the solar system. And we have been able to look at it close up. This is mainly the bright side, which is the side away from the motion of Iapetus. And we believe that this dark material, which there's more of around the other side, is composed, again, of organic molecules. And a big debate that's happening right now is whether this cover of organic molecules welled up from the inside of Iapetus or fell on it from the outside. But I mean, it's a very exciting question.
This is not a question of light. I mean, it appears to be a question of light and shadow.
No, this is real stuff on the surface. The dark stuff is darker than asphalt. The bright stuff is as bright as snow. And the contrast is very striking. We can, adjust the relative contrast between bright and dark. But that's real light and dark on the surface, not a matter of shadow.
All right, Carl Sagan, I'm delighted to say that you will be back with us again tomorrow when Voyager 2 makes its 63,000-mile flyby. Thank you very much. In a moment, we'll visit a group of lobbyists for exploration in deep space. They call themselves the Planetary Society, and there are 80,000 of them. Bluntly put, there is only so much money available in the federal budget for missions in space. The big loser at the moment seems to be the unmanned mission into deep space, missions like Voyager 2. But such missions continue to have their supporters, and many of them belong to a relatively new group which calls itself the Planetary Society. Carl Sagan is its president, and this week, in conjunction with the Voyager 2 mission, the Society is holding a convention of sorts here in Pasadena. They call it Planet Fest. And it began last night with composer John Williams conducting the Pasadena Symphony in a work which, in record form, is even now plunging through deep space aboard Voyager 2, Bach's Brandenburg Concerto.
John Williams, the composer of many space-related themes and now conductor of the Boston Pops, very generously donated himself to conduct the Pasadena Symphony in a concert called Sounds of the Cosmos. It's really an opportunity for the public to get involved in planetary exploration, to share it with not just a few scientists now, but with everyone as the pictures come back from the encounter with Saturn. I think two things are accomplished. One is, of course, is education. People learn, along with scientists, what is out there, what the planets are, what they're made of, what the different dynamic effects are, and all the things we go to the planets to understand our origin and evolution. But even beyond that, people share in the excitement, the adventure of space exploration.
Approach plane, you're actually going to be right here, where that square shows you.
So if you just go right there, you're going to end up
right there. Now the whole idea here is to get into orbit about Saturn once you get there and rendezvous with the space station.
Space exploration is not a scientific endeavor. It's a cultural endeavor. It goes to all parts of our society. The art exhibit, like the concert, is one manifestation of the interest in space exploration. We have 23 artists, I'm told, here exhibiting, over 85 paintings. For the first time since the beginning of the space age, 1982, 1983, 1984, 1985, we'll have 4 straight years with no pictures coming back from any worlds. The point is that the public has always been fascinated with space exploration, wants it to continue, wants to get these kinds of pictures and new discoveries continuously and regularly. We're giving them a place to join to make it happen.
I am all for space exploration. I think it's extremely important to us now and most certainly in the future. And I am all for pushing ahead and keeping it going.
I feel that we need more space exploration for humanitarian reasons beyond what we discover scientifically and so forth.
I know that the present trend is to cut down, to try and get back to fiscal responsibility, but I think we will later on we'll realize we're missing something and go back and pick it up. At least I hope we do.
We're going to bring them the results. We're going to encourage the government to do more exploration. We're going to encourage everyone to participate more in this aspect of what I think is one of the greatest achievements of our society.
In a moment, we'll visit a different Mission Control Center. It began as a high school science project. It has developed, however, into something quite elaborate, involving sophisticated radio equipment and a dish that's collecting signals from a satellite in space. June Massell reports.
Right behind the football field here at Hall High School in Spring Valley, Illinois, is another mission control. The workspace may be a little cramped, the scientist a mere high school student, and the equipment not as sophisticated as NASA's, but it works. And tonight, students and teachers watch some of the same pictures NASA scientists receive from space. How does it compare with classes?
Better, a lot better.
In what way?
It's just neater. Classes are boring.
Here you've seen close-up pictures, nice and clear and everything. You can see everything, and you can see all the moons and all that and everything in there.
The pictures aren't coming directly from Saturn. Instead, they are broadcast by NASA over a satellite 40,000 miles above the Earth and picked up by the students' Earth station, which they built themselves.
First reaction was disbelief because, you know, you're talking about picking up satellites, and we used to practice football out here, and it seems a little bit on the extravagant side. So give it a try. But once the nuts and bolts work came down to it, it wasn't very hard.
They had help from school superintendent Walter Westrom, who found a cheap radar dish at a federal surplus agency.
We were able to purchase this basically for $25.
And the students converted it into a satellite receiving dish. Then it was back to Army surplus for a Radio Shack to house the electronic equipment.
Super deal on that one, too. $450.
In fact, the total cost for everything was just $4,100. Are the students proud? You bet.
We're the only school in the United States with one of these, you know. That's something to be pretty proud of, and you have to think the students put this together. You didn't hire a crew to come in and do this. This was students doing this.
As spectacular as the Saturn pictures are, they may be just the beginning for satellite communications at Hall High. Eventually, school officials want to build a larger dish to pick up international transmissions, and who knows, maybe even tune into the evening news from the Soviet Union. June Massell, ABC News, Spring Valley, Illinois.
Tomorrow, we'll be looking into the somewhat questionable future of unmanned space exploration as Voyager 2 moves to within 63,000 miles of Saturn. We'll be coming to you live once again from the Jet Propulsion Laboratory in Pasadena. Carl Sagan will be with us again, as will the President's new science advisor, Dr. George Keyworth, and one of America's great science fiction writers, Ray Bradbury. That's our report for tonight. This is Ted Koppel in Pasadena, California. For all of us at ABC News, good night.
This has been ABC News Nightline.